Okay, this is question I got on powers of complex numbers. And it's I think it's probably at the very end of the complex numbers chapter. It's a little tricky. I actually had to go in myself and remind myself how to go through this because there's some little tricks. Anyway, we've got z to the fifth is equal to 32. Okay, and we want to find out what the value of the complex number is right here. And there's actually a whole bunch of solutions, and we're told to find the solution whose argument is strictly between 0 and 90 degrees. That means whose angle, in the excuse me, whose angle in the polar form of the complex number is between 0 and 90. So here's my work. Let me take you through my steps. Okay, just start with the basic equation. The first thing you want to do is to convert your number into the polar form. This is your complex number. It's also just a plain old number, but convert it into the polar form of that number. And that's another skill earlier on in the section. So hopefully that's not too troubling for you right now. If it is, just go back and review or ask me a question. I can do another video on that skill. So I just converted 32 into its polar form. And then this is the point I was kind of missing before. You want, even though 0 is where this angle 0 is where 32 is on the complex plane, any 360 degree rotation of that point will still be a solution. So it's plus 360n, plus 360n. Okay. And then we're going to root fifth root both sides of the equations once we have it all set up in polar form and generalized for all solutions. Okay. The reason that we've converted into polar form is that rooting complex numbers is really easy once you are seeing the polar form of it. It's very difficult it's hard to do in the rectangular form. So to just root it, this is multiplication, so we can split the root up between these two things. And I'm going to root the left side, which is 32, that just ends up being 2 here. And if I root all the stuff with the trig functions in the I, that really just involves dividing the angle by 5. So this is just a rule of how you root complex numbers. Right, same thing. If you're going the opposite direction, you're exponentiating them. You're going to multiply the angles by whatever the exponent is. Like if you're raising it to the 4th power, you multiply all the angles by 4, and you take the radius and you raise it to the 4th. Okay, so it's just going in reverse. I'm dividing and I'm rooting instead of exponentiating and multiplying. And so the 5th root of 32 is just 2. Here we have to divide both the 0 and the 360 by 5. And I know some of you might not want to keep that 0 in there. In general, we kind of got a nice angle. We got a nice angle for our problem here, but it could be harder if that was like 30 or 45 degrees or something. So I just keep it in there. So I divide 0 by 5 and then 360 by 5 to get 0 plus 72n. Okay, and the same thing happens over here with the sign. And then here's where we have to take into account what they asked us over here, that the arguments of the polar form of the complex number be between 0 and 90. So we just want to find out which n would make 0 plus 72 between 0 and 90, and that's a 1. It's like the first turn of the number. So we're just going to let the angle be, instead of this generalized solution, we're just going to look for this specific solution that they want and let the angle be 72. Okay. Now any of like 0, I could put 0 here. That's or I could put, what's twice 72, 144 here, and it would also be a solution, but they want a specific solution. From here, I just distribute the 2 and then get decimal approximations for each of the x value and the y value. Okay.